Hello, today we are going to talk about a very important concept, which is the limit of a sequence. Last time we had done some exercises involving this definition, but as I have said, I hadn't explained it at that time. I just want you to be familiar with what we are using. But to be more clear, I've decided to make this video, okay, which will explain entirely what the limit is, okay, by using this definition that I've written over here. So xn converges to x, or we can say that x is a limit of xn if for all epsilon greater than 0 there exists a natural number n, so that xn minus x is less than epsilon whenever n greater than n. So you need to be very familiar with this one. That is why I've decided to make this video. So over here you see there are two important things, okay, two of them. This one, epsilon greater than 0, it basically says that epsilon should be a real number that is positive, okay. So epsilon, if you have to note it down, you will have to say that it should be a positive real number, okay. For example, 0.1, 0.0002, okay. It can even be a natural number 1, 2, 1.1, and so on, okay. It can be any positive real number. And over here n, it should be a natural number, okay. N belongs to n, okay. So it should be very clear, okay. So this is what we are going to do. Whenever we have to check that xn converges to x, okay, firstly we need to know what the value of x is. We need to have an idea what the value of x is, okay. That can be done, as you will see later on. And also think of this one as a game. The game is that I am giving you epsilon, okay. I am giving you a real number, and you have to give me a natural number that satisfies this condition, okay. If for every real number that I give to you, you can also give me a corresponding natural number, then we will say that xn converges to x, okay. So keep that in mind. I will give you epsilon, you will have to provide the natural number n, okay, that satisfies this condition, okay. So let's see. All right, I won't erase this definition because you will really need it, okay. I usually explain this one with the help of an example, xn equal 1 by n. Okay, so first we need to have an idea what the value of x is. So over here xn, it's 1 by n, it converges to 0. Okay, how do we know that it is 0? Because if n is very large, then 1 by n, it's equal to 0. Okay, so we are getting this x equal to 0. Now to fully understand what this means, okay, firstly let us calculate x1 minus x, x2 minus x, okay. So you will need to calculate all of these, okay. So x1 minus x, it will be 1 by 1 minus 0, which is equal to 1. 1 by 2 minus 0, which is equal to 1 by 2. Similarly, you can calculate x3 minus x, you will be having 1 by 3, okay. Just fill in everywhere. X4 minus x, you keep on calculating all of these, okay. X4 minus x, x5 minus x, keep on doing it, okay, till infinity, okay. I know that you won't be able to do it, but at least we are having an idea what their values are, okay. So now starts our game, okay. So now that we have calculated this one, now starts our game. I will give you epsilon, you will have to provide me capital N, okay. So let us say epsilon, it should be greater than 0, okay. So I am giving you epsilon, and you have to provide this natural number n, okay. I will give this value over here, you will have to provide the corresponding values over here. Okay, I will start with a very easy one. Let's say epsilon equal 2. Okay, since you have to provide a natural number, okay, so you can either provide n equal 1. Okay, so these are your choices. Which of these will you choose? Okay, of course there may be so many values that you can choose, but at least you should choose one. There exists at least one. Okay, even though it's not mentioned over here, but whenever we are using the word there exists, it means there exists at least one natural number n. Okay, so let us see. If you give 1, okay, let us say that you are giving me this n equal 1. We will check whether it satisfies this condition or not. Okay, if you check whether capital N equal 1 satisfies this condition, then you must note this one first. N greater than n. Okay, so n greater than n. So what are we having? So n, it is greater than capital N, so n will be 2, 3, 4, 5, 6, and so on. Okay, so n can take so many values. Okay, maybe I will write it again. So we were in this stage. I am giving you epsilon equal 2. Suppose you are giving me natural number n equal 1. Then we want to check this condition. So first, let us see what the value of n is. N should be greater than n, so n will be 2, 3, 4, and so on. For each of these values, you will have to check whether xn minus x is less than epsilon. Now let us check. Okay, so first put n equal to 2. x2 minus x, you are getting 1 by 2. Is it less than epsilon? Is it less than 2? Yes, it is less than epsilon. Now check for n equal to 3, small n equal to 3. So you will be getting x3 minus x. x3 minus x, it's equal to 1 by 3. x3 minus x, it's equal to 1 by 3. Is it less than epsilon equal to 2? Yes. Okay, now again check for x4 minus x. Are you getting that this is less than epsilon? x4 minus x, it is 1 by 4. Of course, it is less than epsilon. Okay, so even if you check for 5, for 6, and so on, okay, all of them will be less than epsilon. Okay, so that's why I'm writing a tick mark everywhere. Okay, so because for every n greater than this natural number n, we are having xn minus x less than epsilon. Okay, so we can safely conclude that for this epsilon that I'm giving you, capital N is equal to 1. Okay, you can even choose capital N equal to 2. Okay, because if you choose capital N equal to 2, then n will be 3, 4, 5, and you will see that xn minus x is less than epsilon. Okay, so it's very simple. Now I will give you another value of epsilon. Okay, I will make it much more difficult this time. Let's say epsilon equals 0.1. It is still possible because epsilon is greater than 0. So this one is still greater than 0. Now let us see. Okay, again you will have to provide a natural number capital N. So these are your choices. Okay, suppose I give 5. Okay, suppose I am giving the number 5. Now you will have to check n. N will be greater than n, so it's the possible values are 6, 7, 8, 9, and so on. For each of these values, we will calculate xn minus x and check whether it's less than this epsilon or not. Okay, so let's see. x6 minus x. Is it less than epsilon? Okay, So if you calculate x6 minus x, it will be 1 by 6 minus 0 equal 1 by 6. Is it less than 0.1? Okay. Is it less than epsilon equal 0.1? You will see that no. Okay, so no. All right, so if it doesn't work for 6, okay, you don't even need to check for 7, 8, 9 because it already fails for one of the values. So that is why, what can we say? For epsilon equals 0.1, you cannot give me capital N equal to 5. Okay, but you may try to give another value. Let us say you are giving another value, which is 11. Okay, you can do that. You can do that because the choice of N, it's yours. And you can choose from these numbers. 5 may not work, but other numbers may work. 6, 7, 8, 9, 10, 11, or 12, or 100, or 1000. So over here we have chosen 11. So if we have chosen 11, okay, let us choose 10, okay. 11, you can choose 11 also, it doesn't really matter. Okay, it's your choice, as I repeat. Okay, so now let us calculate these. For these values, let us calculate xn minus x. Okay, so you will be getting x11 minus x. Again, if you repeat this process, you will be getting 1 by 11. Is it less than 0.1? Is it less than 0.1? If you calculate, yes. Okay, so yes, it is less than epsilon. x12 minus x, because you also have to check for 12. It will be 1 by 12. Is it less than 0.1? Yes, it is. Now, similarly, if you check for 13, you will see that it is still less. So for all of these values, you are always getting that xn minus x is less than epsilon. Okay, so this value of n that you are giving, it works. Okay, before you were giving 5, it doesn't work, but if you give 10, it will work. Okay, now I will make it more difficult. Okay, now let us say I give you 0.01. Okay, if you take n equal to 10, again it will not work. Okay, because 1 by 11, now the value has changed, epsilon has changed. Okay, I am giving you another epsilon 0.01. Okay, it does not work. Okay, so 10 will no longer work. But again, you still have some other choices for n that you can give me. I have given you epsilon equals 0.01. Now you will give me a natural number and you have so many choices. Okay, if you choose 100, you will see that it will work. It will work because now small n will be 101, 102, 103, and so on. And if you calculate, okay, all of these are smaller than epsilon. Okay, from this, what can we have an idea? We are getting an idea that if I give you any epsilon, okay, whatever the value of epsilon may be, I may even give you a very small one. Okay, you can always find a corresponding natural number n. Okay, let's say over here 10,000. Okay, so whenever I give you epsilon, you are able to find a natural number n. So that, okay, for any epsilon that I give you, you are able to find a natural number n, so that whenever it is bigger than xn minus x is less than epsilon. Okay, so when this happens, that is, if for every epsilon that I give you, you can always find a natural number n, then in that case, we will say that xn converges to x. Okay, so I hope that is clear. Okay, and okay, so I hope that is clear. But when will we say that it does not converge to x? Does not converge to x. Okay, if so, over here you are having for every. Now you will replace it for one value of epsilon greater than 0. That is, you just need a particular value of epsilon that is greater than 0. There does not exist a natural number. Whenever n greater than n. So if it converges, then for every we can give a natural number. But it does not converge to x if for one value there does not exist. Okay, whenever n greater than n. Okay, so this is when it doesn't converge to x. Again, I will give you an example. Okay, just for you to understand. Okay, so let's say xn it's equal to minus 1 to power n. Okay, if you expand this one, then you will be getting x1 equal minus 1, x2 is equal to 1, x3 equal minus 1, and so on. Okay, it keeps on alternating. Okay, suppose I show that xn does not converge to x equal to 1. Okay, show that it does not converge to x equal to 1. Okay, what will we do? I will give a particular value of epsilon, because remember that if it does not converge, then we just need a particular value of epsilon. Okay, let us say 0.1. I will make it very small. Okay, now I will see x1 minus x, x2 minus x, x3 minus x. Okay, I will calculate x4 minus x, and so on. So x is equal to 1, x1, okay, it will be minus 1, which is equal to 2. And if you calculate this one, minus 1 equal to 0. So it keeps on alternating 2, 0, 2, 0 in this way. Now, okay, you just check. Is this one smaller than epsilon? No, it's not smaller than epsilon. This one, is it smaller? Yes. Not smaller, smaller than epsilon. Okay, what can we say from over here? There does not exist. So that xn minus x less than epsilon for all n greater than n. Okay, just like I was saying, I am giving epsilon, you have to give me natural number n. If you give over here n equal to 1, then you know that this value of small n will be 2, 3, 4. Okay, 2, 3, 4. Are all of them smaller than epsilon? Because over here you are having the word for every. Are all of them smaller than epsilon? No. Okay, so n cannot be 1. Now if you choose the value n equal to 2, then you will have to check from n equal 3, 4, 5, 6. Okay, n equal 3, 4, 5, 6. Now check all of them. Are all of them smaller than epsilon? You can easily tell no. Okay, so that's why n equal 2 will not work. Now you can again check n equal to 3. Okay, suppose you are giving me this n equal to 3. Okay, whether it works or not. But you will see that will not work, because these numbers, all of them are not smaller than epsilon. Okay, of course a few of them are smaller than epsilon, but there are also numbers, there are also these terms which are not smaller than epsilon. For example, x5. Okay, so that's why it will not work. Similarly, you get an idea that even if you put n equal to 4, it will not work. Even if you put n equal to 5, it will not work. Okay, because it keeps on alternating. There will always be some terms that are not smaller than epsilon. Okay, so that is why it does not converge to x, because for epsilon equal to 0.1, there does not exist n belongs to n, so that xn minus n is less than epsilon for all n greater than n. Okay, so I hope that is clear. Okay, again, if it is not clear, just have a look again at the video, just rewind it. Then if you have any difficulties, you can post in the comments. Okay, that is always acceptable. I will always try to respond to the comments. Okay, so now that the limit of a sequence is clear, we will prove this theorem. The limit of a sequence is unique. Okay, that is, if there is a limit, then there will only be one limit. There cannot be two limits for a sequence. For example, okay, 1 by n, it only converges to 0. It cannot converge to any other value. Okay, let us say 1 by 10,000. Okay, it will not converge to this number. It will not converge to any other number because it already converges to 0. That is, there can only be one limit for one sequence if it exists. Okay, the limit, if it exists, of a sequence is unique. Okay, so let's see the proof. Okay, but before doing the proof, you will need this idea about the triangle inequality. Okay, so the idea about the triangle inequality is that the sum of the two sides of a triangle is greater than the third side. How will we write it down? Okay, this is how we will write it down. A plus b less than or equal a plus b. Okay, so we will need this idea to prove this theorem. Okay, so we have to show that the sequence, the limit of a sequence is unique. So first of all, we will need the sequence at xn be the sequence. So what will we do? Again, we will do it with contradiction. Suppose it is not unique. Suppose the limit of xn is not unique. Then, if it is not unique, that means there are more than one, okay, there are more than one limits. Okay, let's say that there are two limits. That is, suppose there are two limits. Suppose xn converges to x and xn converges to another sequence or to another real number, which is y. Okay, suppose this happens. Okay, we will show that it is in fact impossible if this happens. Okay, where x and y are different. Okay, suppose xn converges to x. Okay, and xn converges to y, where x and y are different. If x and y are different, then x minus y is greater than 0. Okay, if x and y are different, subtract them. Okay, then take the modulus, it will be greater than 0. Okay, that is true. Okay, for example, if x is 0.1 and y equal to 0.2, they are different. So if you take the modulus of x minus y, it will be greater than 0. Okay, if this is greater than 0, then if you divide it by 2, it will also be greater than 0, right? A positive number, you divide it by 2, it will still be greater than 0. Okay, so now what will we do? We will take epsilon, it can be any positive real number. So this one, it is a positive real number. Okay, take epsilon equal to this, which is a positive real number. Okay, but since xn converges to x, if you use the definition, then for epsilon equal x minus y by 2, there exists n belongs to n. Okay, I can even replace it with n1. Okay, it is a natural number, that is fine. Okay, sometimes you will use n, sometimes you will use n2, n3, and so on. It's just a notation, so that xn minus x, that's an epsilon, for all n greater than n, that is xn minus x less than x minus y upon 2 for all n greater than n. Okay, so xn converges to x, but also xn converges to y. Okay, because we have said that x and y are the limits. We have assumed that. Okay, then similarly for epsilon, there exists n2 belongs to n, so that xn minus x less than epsilon for all n greater than n2. Okay, so over here it's n1, that is xn minus x less than x minus y upon 2 for all n greater than n2. Okay, so I will keep this one as equation 1. Oh, sorry, this one it's y. xn converges to y. I will keep this one as 2. Okay, so what are we noticing over here? This n1, it works for this epsilon and it works for this x. n1 works for this epsilon and for x. n2, it works for epsilon and it works for y. Okay, so what will we do now? Now we will try to use this inequality. Okay, so a plus b, so I will write x minus y. Okay, now this one we can simply write it as x minus xn plus xn minus y. Okay, so this is what we are getting. Now we can split this one in this way. Okay, minus xn minus x plus xn minus y. Okay, so this is what we are getting. Now take this one as a, take this one as b, and use the triangle inequality. Okay, take this whole thing as a, take this one as b, so you will be getting that it is less than minus xn minus x plus xn minus y. Take this one as a and b, and by the triangle inequality. Okay, but this one, it's equal. Okay, so this one now it's equal to, so over here I'm having negative sign, xn minus x, xn minus x, it's less than epsilon. Okay, it's less than epsilon, and this one also it's less than epsilon for all n greater than the maximum n1, n2. Okay, so how do I know that I will have to take the maximum? Because equation 1, it works for n greater than n1. Okay, equation 1, it works for n greater than n1. xn minus x less than epsilon when n is greater than n1. xn minus 1 minus y, it's less than epsilon when n is greater than n2. Okay, so if we take the maximum, then n will be greater than n1 and n will be greater than n2 as well. Okay, so that is why both of these hold at the same time, so that's why it works. Okay, so this one is actually equal to epsilon, which is a minus b by 2 plus a minus b by 2, which is a minus b, sorry, x minus y. Okay, I made a mistake. Epsilon, if you notice from the very beginning, we had taken it to be x minus y upon 2. Now just see, is this possible? X minus y, it's less than x minus y. Is it possible or not? These are both same quantities. One is less than the other. Okay, it cannot be possible. Impossible. So our assumption is wrong, therefore the limit is unique. Okay, so this completes the proof. The main idea over here is that you should take the maximum. Okay, so this actually works in most of the cases, okay, where you have to take the maximum, because the first one, it works when n is greater than n1, and the second one works for n it's greater than n2. So if you take n to be the maximum of n1 and n2, okay, take the bigger one. If you take the bigger one, then it will work for this and it will work for this as well. Okay, so I hope you are getting the idea. Until next time.